In this example, we are going to construct a confidence interval for the mean where sigma is known. Example, a college admissions officer takes a simple random sample of 100 entering freshmen and computes their mean mathematics SAT score to be 458. Assume the population standard deviation is sigma equal 116. Construct a 99% confidence interval estimate for the mean. Round your final answer to whole numbers and then make sure to interpret your final answer. So first, let's make sure we understand all parts of this question. So first of all, what is the population we are studying here? Okay, so the population is just the entering freshman class. Okay, 100 students, this is not the population. The population is all entering freshmen. Okay, so the entering freshman class. The 100 students is actually just the sample. So do we know what mu is? So remember, mu is the population mean. Okay, and in this case, the value is unknown. That's exactly what we're trying to estimate, right? So when we are asked over here, construct a 99% confidence interval for the mean, we are trying to estimate the population mean. So mu is unknown. We do not know the mean SAT score of the entering freshman. What we do have, though, is we have a sample of 100 of these entering freshmen, and we have their mean SAT score, and that is 458. So that is our sample mean. So I'm just going to make sure that's clear. X bar equal 458 is the sample mean. And that is what we would call a point estimate for the population mean mu. We also know the population standard deviation. That is given. So good to know. Sigma is 116. That is a parameter. That's the population standard deviation. Okay, so when you first read a question, just make sure that you understand what the population is and what the sample is, and don't get them confused. And understand what you're trying to do. With a confidence interval, we are trying to estimate the population parameter, so in this case, the population mean. So let's move on from there. The very first thing that I'm going to do is I'm just going to make sure the conditions are satisfied so that I can use the confidence interval methods from our text. The first thing I notice is that sigma is known. So the population standard deviation is known, even though we do not know the population mean. In this particular case, we do know the population standard deviation, which is a rare case. Usually, if you don't know the population mean, you don't know the population standard deviation. But in this case, we do. Also, we have a simple random sample. And note that the sample size is equal to 100, which is greater than 30. So that's a large sample. And this implies we can use the central limit theorem, the distribution of sample means. Is approximately normal. Okay, so all the conditions are met. I take a look at what I'm given. We were given n equal 100. The sample mean was 458. Our point estimate Population standard deviation was 116. Mu is the unknown. That's what we're trying to estimate with our interval. So in this case, we can use the 99% confidence interval formula, and that is okay, so I'm going to go ahead and fill in my numbers into the formula. So this would give me sample mean was 458 plus or minus 2.576, and the standard population standard deviation divided by the square root of 100. So if I were to just pop this whole thing into my calculator, I would get two numbers, and subtracting, we get 428.11, and I'm going to stop there because I'm going to be rounding to a whole number, and then 487.88, and I'm just going to stop there. And if I round, this gives me the interval 428 and 488. So this is my confidence interval. Okay. There are a couple of other ways that you can write your confidence interval. So first, of course, we have this interval notation. You could also write your confidence interval as an inequality. So this is saying that the population mean is between 428, mu is between 428 and 488. You can also write it in terms of the point estimate, so the sample mean, and the rounded margin of error. Okay, so these are all ways that you could write your confidence interval. So just in more general notation, this one is x bar minus the margin of error, and this is comma x bar plus the margin of error. This one, the second one you see is x bar minus the margin error is less than mu, which is less than x bar plus the margin of error. And finally, we have x bar plus or minus the margin of error. So here's one way to do it. You could say we are 99% confident the mean SAT math score of the entering freshman class is between 428 and 488 points. Okay, just to point out some important things here, to be on the safe side, you can always start off with we are 99% confident. Okay, express your confidence level or the probability. Also, make sure you want to clearly state your parameter. We are estimating a mean, and it is the mean SAT math score. So always state the parameter specifically. And you also want to make sure you state the population. This is my population. And, of course, the information given by the confidence interval. So when you state the parameter and the population, make sure you don't make the mistake of stating sample values. Like I've seen common errors. We are 99% confident. The sample mean SAT math score of the 100 students in the sample is between 428 and 488, which would be completely wrong. The sample was just what allowed us to estimate the population parameter for the population of the entering freshman class. A second way that you can interpret the confidence interval that's a little bit different, and it is based more on the writing the confidence interval in this format, okay, is that, again, I'm always going to start with we are 99% confident. That by using 458 to estimate the mean SAT math score of the entering freshman class, we are off by no more than 30 points. Okay, so again, you see I give my confidence level. I make sure to clearly state the parameter I'm estimating and the population, and make sure not to confuse it with the sample. And then I use a slightly different phrasing.